In the beginning, let us define the IoT framework and programming framework. The IoT framework is a set of tools, firmware, and various devices, and sometimes hardware delivered as is. It provides developers with configuration capabilities. The programming framework, on the other hand, is an environment for low-level, usually bare metal programming, commonly referred to as a software development kit or shortly SDK. We focus on the second one, particularly on C and C++ programming. Almost every microcontroller vendor develops its own SDK, providing programmers with a specific programming framework. It is worth noting that in many cases it follows the general programming construction of the source files for C or C++. This programming framework provides access to all features of the hardware. A common approach is to use a graphical user interface to automate the generation of the source code stub that contains the hardware-specific configurations such as timers, GPIOs, and interrupts to avoid monotonous and complex tasks and speed up development. Still, development usually requires a rigorous approach to inject user-specific code only in predefined locations of the source files. Otherwise, it may break the source code, or even the user's code may be deleted when regenerating configuration using SDK tools and automation. A sample main function for the STM32 MCU is presented in the following listing. Note the hints in the automatically generated source code. Developers are intended to fill their code only in predefined areas, such as starting from user code begin init and finishing before user code end init. Otherwise, the user source code will be gone when updating the configuration. Studying specific platforms is time-consuming, and as each vendor has its own approach, knowledge and source codes are usually not portable between microcontrollers. Typical C++ code, as presented above, is a single-pass execution. On the other hand, IoT devices used to work infinitely, handling their duties such as reading sensors, communicating over the network, sending and receiving data, routing messages, and so on, thus requiring setting up an infinite while-one loop for processing. Moreover, many tasks must be done in parallel, so a task scheduling mechanism should be included to run multiple tasks synchronously. A common use is to include the FreeRTO real-time operating system or its modified versions to the specific hardware platform provided by the hardware vendor.